Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi everybody. So how are you? So hopefully you are doing well. Wherever you are, please stay at home. Alright. Okay. So as I mentioned, as far as we're concerned, we need to continue our lectures using this approach. So our last topic before is balancing. Alright, and balancing for rotating masses. So now we continue with a next topic, also balancing, but for this moment we look at the topic about reciprocating masses. So what is reciprocating is actually? Okay, so before we start, we need to know that this topic is basically covered on the CLO number 3, which is to analyze and solve problem in balancing of rotating and reciprocating machineries. Okay, so reciprocating is actually we are going to analyze the unbalanced condition of the device. So actually reciprocative, we can look at this kind of device in the car, isn't it? Because this one is basically we call as the what we call the engine, all right, the process of combustion engine. So we have four steps: we have intake, we have compression, we have expansion, and we have exhaust. So macam mana kita nak kaitkan dengan balancing ni? So basically actually what happened on all these four piston, we have some kind of unbalanced masses that occurs for each uh, piston. All right, so that's why we need to analyze what kind of uh, balancing masses that occurs on each piston. So look at this one. This is example of the piston. We have how many stroke here? We have 1 2 3, sorry, how many piston? We have 4 piston. 1 2 3 and 4. Okay, this one example of what we call a reciprocating for radial type. All right, this one is for inline. This one we call as radial. So we are going to look at how many types we have under this topic after this. All right, so look at this one, how all pistons is moving, is rotating. All right, this one is type of V line, we call as V line type. All right, so V line type. Okay, so that one is some of examples of engine that we can actually investigate on this relating to this topic. All right, so a large class of machines have rotating and reciprocating parts. All right, we already rotating and reciprocating parts. So for example, internal combustion engine. All right, so for reciprocating machineries, a piston reciprocating in a cylinder and connected to crankshaft by a connecting rod. All right, unbalanced force, the resultant of all forces acting on the engine due to internal forces. So due to the rotation of a cylinder, so of course uh, some unbalanced force will occur. All right, so this kind of unbalanced force will be affect the what we call the will affect the system or the mechanism of the ICE. All right, So balancing the reciprocating masses. So why we need to balance these masses? The the purpose is to eliminate the unbalanced force and couple. Alright, we need to eliminate the unbalanced force and couple. So, or in other words, we need to ensure that our system must be balanced. Alright, our system must be balanced. So, how to balance it? So, we can actually add some appropriate balancing mass, or we can also reduce but not practical to eliminate completely. Only partially balanced. Why only partially balanced? Then we are going to look at after this. Okay, before we move to types of engine, we must know the relationship piston crank angle. All right, relationship piston crank angle. All right, this one is we call as a piston. All right, piston, and this is stroke. This is connecting shaft, connecting rod. So this is piston. Piston is moving horizontally to the right, to the left, to the right, to the left due to the movement of here. All right, crankshaft. So BDC is bottom dead center, TDC is top dead center. So actually, as this one is rotated, what happened to our piston must be moving vertically, isn't it? Right? Must be moving vertically. So this is other things that you must know. R is radius here, from here to here, and L is length from BDC to TDC, length of connecting rod. This one is radius of crankshaft. This is crankshaft. And angle is angle between the crank and line of stroke. This one. And phi. What is phi? Angle between the connecting rod and line of stroke. Stroke. So means that stroke equals to 2R. Right? Stroke. This is stroke. Length of stroke or dimension of stroke is actually equals to 2R. Okay? And another one is you must know is N is L over R. What is our N? Number of stroke. Okay. So this thing you must know. You must remember this. Stroke, alright, I repeat again, stroke equals to 2R and N equals to L over R. Alright. So as if you look at this figure, how to find X actually? Actually, X is basically we can find or we can define it as R cos theta plus R cos theta X equals to R cos theta, isn't it? This one, this is our R cos theta. Okay, plus with L cos phi. This is L cos phi. L cos phi. So we can find what is our R. So this is our definition of R. X, sorry. And then we differentiate with respect to time, then we get velocity v equals to dx over dt equals to x dot also equals to negative omega r sine theta plus tan to theta over 2n. And we differentiate again, then we get acceleration, which is a. What happened to my pen? Okay, so we have a equals to dv over dx equals to x double dot negative. So this is our equation of displacement, velocity, and acceleration. Right? So how to relate with the force acting on the piston? Since we know that we have force of shaft, which is direction to the right, also force of piston, direction to the left. Alright, so how to find F sharp? Since we know that we have equation based on second Newton law, F equals ma, then A is actually comes from the relationship from here. So A is omega negative omega square r cos theta plus cos 2 theta over n. Then just input it into this formula, then we get this formula. So m omega square r cos theta plus cos 2 theta over n. And then we finalize our answer, so our force, then we obtain that our force acting on the shaft must be m omega square r cos theta plus m omega square r over n cos 2 theta. Okay, so basically we get these two forces actually. First is primary force and second is secondary force. What is the differences between primary and secondary force? Okay, we look at after this. So this one is primary force. Primary force is actually, if you can realize that what happened to our force here. Okay, if you look at this one, sorry. Okay, so this one is actually force. Okay, force shaft. It could be here. All right, it could be here. It could be here. It just depends on the movement of piston. So piston is moving to the right or to the left, making our crankshaft is rotated. So our force should be like this. All right, so what is our force? Mr omega squared. This one we call as primary force, Mr omega squared. And how about secondary force? All right, we have Mr squared over n 2 theta, should be 2 theta because due to this formula. So just remember this. Force, actually we have two types of forces. First is primary force and another one is secondary force. All right. So the primary force Fp reach maximum value when theta equals to 0 and 180 degree. Why? Because we know that we have this kind of formula, mr square r cos theta. We know that Fp equals to mr omega square cos theta. When theta is 0, or 180, then we get maximum Fp, isn't it? Maximum Fp. And then the secondary force reach maximum value 4 times per revolution when theta is 0, 90 degree, 180 and 207. Because based on this formula, we input our theta with the values, then we get this kind of value, then we get our maximum secondary force. So F piston constant in direction but varying in magnitude, but F equivalent constant in magnitude but varying in direction. So actually this one we call as F equivalent equals to what? Fp plus Fs. F primary plus F secondary. Alright, and this is our PF piston. Alright, is that clear? Okay, so equivalent mass only partially balance the reciprocating system. Why? Because look at this one. Actually, once F we have the force here. Okay, what happened? On the only balance is occurs on the horizontal line because F cos equivalent cos theta we have supported by F piston, so that summation of force X equals to 0. But what happened to F equal to cos theta, sin theta? Then it's not balanced because we have no other forces that can support this force. So that's why we call as partially balanced. So S has relatively smaller magnitude, all right, not particular to balance, binomial expansion. So we have primary force, secondary force, etc. etc. So means that the value of secondary force should be smaller should be smaller. All right. So these are the things that you must know. All right, balance condition. So we need to investigate the unbalance. We have three types of engine. First, if we have inline engine. Second, we have radial engine, and third is we have V engine. So as for inline engine, all right, we are going to investigate these four types. We need to find, or we need to investigate whether the primary force is balanced or not, whether secondary force is balanced or not, whether primary moment is balanced or not, or whether secondary moment is balanced or not. You must ensure that you must know, or you must investigate each one of these, and whether this one is balanced or not. Alright, as for radial engine, what we're going to investigate is we need to investigate force of primary direct. We need also investigate reverse, primary reverse. This one is secondary direct, and this one is secondary reverse. Same thing what happened on V engine. So we have these three types. We have inline engine. Remember this, we have inline engine, we have radial engine, we have V engine. So during exam or during test, the first thing that you must know is types of engine. All right, for example, if we have an inline engine, so what are the things that you must investigate? So we have for these four uh, things that you must investigate. If we have a radial engine and V engine, so this four forces that you must investigate. All right. So we look at the first types of engine, inline engine. Inline engine is basically exists of stroke are parallel to each other, similar to balancing of multiplane rotating masses. So this one is very common engine that we can see inside the car, isn't it? So reference plane located at the plane symmetry of engine arrangement. So normally we look the reference. Why this one we call as reference plane? Because this one we are need to investigate the condition of moment. All right. So the mass, crank radius r, length of connecting rod L, and angular speed omega are usually the same for all cylinders. All right. M, R, L should be the same. So firing order, what is firing order? The order in which each cylinder experiences the power stroke in one cycle, depending upon the number of cylinders and strokes of each engine. So for example, if we have 4 cylinders, our firing order is maybe 1, 2, 3, 4, 1, 3, 2, 4, or etc. etc. If we have 6 cylinder, means that maybe we have 1, 2, 3, 4, 5, 6, 1, 4, 1, 5, 3, 2, 4, 6. So this is how many cylinders we have, depends on the condition lah. All right. So look at this one. This is an example of another. For example, this one we have V cylinder. So fire radiator maybe 1, 4, 2, 3. It is actually look at the angle. All right, 1 means that starting with 1, and then next is the piston is moving, number 4, next is number 2, and next number 3. For inline cylinder like this, 1, 2, 4, 3. All right, 1, 2, 4, 3, because of this one. Look at from this view. All right, look at from this view, we can actually look at the angle of each piston. So that's why inline cylinder engine is 1, 2, 4, 3. Which piston is come first? First is number 1. All right, and the second is number 2 maybe. Third is number 4, and last one is number 3. All right, last one number. It just depends on the question. All right, so don't worry. So I will explain later about this. All right, so look at this one, 1, 2, 3, 4. All right, angle interval is very important. So Once we know that how many strokes we have, and once we know that how many cylinders we have, then we can actually find the find the angle interval. So how to find the angle interval? For example, if during exam, the question asks us about two stroke only. So two stroke means that the cycle of operation is complete in one revolution. One revolution means that we have 360 degree. So how to find the angle? 360 divided by n. N is number of cylinder. Maybe 4, more, maybe 6, depends. Alright. Okay, so for example, if number of cylinders is 4, means that 360 divided by 4. So equals to 90, isn't it? 90 degree. 90 degree divided by 4. And for example, if the cycle of operation is complete in 2 revolution, so how to find theta? For example, number of cylinders here is n is 4, so means that 7 T0 divided by 4 equals to 180, isn't it? 180. So this is the way how we can find the angle interval. Okay, look at this example. Determine the location of equivalent masses of the following. Number A, a 4-stroke 6-cylinder engine with firing order 153624. 153624. So what is our angle interval? What is our angle interval? Let's say this is A and this is for B. So angle interval, so theta should be 4 stroke. 4 stroke means that we have 7 to 0, isn't it? Divided by 6. So the answer must be 7 to 0 divided by 6. Should be, wait. 7 to 0. 7 to 0 divided by 6 should be 1 to 0. 1 to 0. So we can actually draw the firing order 1 to 0 here. So each of this one is 1 to 0 degree. Okay, 1 to 0. So our firing order must be number 1 should be here. Alright, and then go to 1 to 0, number 5, go to number 3 here, and then back to number 6 here, and then 6, 4 here, and 2 here, and 4 here. So 1, 6, 5, 2, 3, 4 should be 2 cycle, because 4 stroke should be 2 cycle. How about secondary? Secondary is basically 2 theta. 2 theta, just draw back our, here is 1 to 0, 1 to 0, 1 to 0 degree. Then we know that starting with number 1, and then number 1 to 5 should be 240, isn't it? So to 240, go to here, and then should be here 5, and then again 5 to 3 is 240, should be here. 3 to 6 should be here. All right. 1, 5, 3, 3 to 6 should be here. 6 to 4 should be here. Sorry, 6 to 2 should be here, and 2 to 4 should be here. Right, should be here. So this is our now firing order. So actually this one, if we look at this one is already balanced, isn't it? Because direction of force is here. Already balanced. This one also balanced for primary force. Sorry, secondary force. This is primary force balance. So this one also balanced. Number B, 2-stroke of 4-cylinder engine with fire order 1, 3, 2, 4. So theta equals to 2-stroke means that 360 divided by 4 means that we have 90 degree. So how to find here is like this. So it should be number 1, number 3, number 2, and number 4. And how about secondary? Should be number 1 here, and should be 2 theta. So 2 theta means that each of this one should be 180. Number 1, number 3, number 2, and number 4. So all this is already balanced, right? Balance. This one is also balanced. Okay, clear. So there was not much difficult to understand it. Okay, this is some of example of the uh, condition of mass 1. Look at this one. This one is M1. So F1. So M1 R omega squared. So look at the condition of it should be upward, isn't it? Upward is here. And then number 2. Number 2 is going to this way. F2. Number 3 is downward. F3, and number 4 is here. F4. So this one is balanced. So this is fast. And reference planes means that we assume that from each shaft here, our reference plane should be in the middle. Alright, in the middle. Why we need this? Because we need to investigate the moment. So reference planes, let's say this is number 1, number 2, number 3, number 4. So this is our reference planes lah. Alright. Okay, this is the answer what we discussed before. Okay, this is cylinder arrangement. Okay, look at this example. Investigate the balance condition of 4-stroke 5-cylinder in engine firing order 15243 with respect to engine central plane of symmetry. So we have piston mass m kilogram, crank radius rm, length of connecting rod lm, and distance between cylinder d and angular velocity is omega. So how to solve? First is you must know the angle interval. Since this one is 4-stroke engine, so 70 divided by n. What is our n? 5 cylinders. So that's why divided by 5. So 1444 each. So 2 theta is 288. So first is we just construct our table. This is plane 1, 2, 3, 4, 5. MR, D here. Why negative? Because this is plane 1, 2, 3, 4, 5. Our reference should be occurs at point. That's number 3, plane number 3. So to the left is negative, to the right is positive. So number 1 and number 2 should be negative 2 MRD, negative MRD 0, MRD 2, MRD. So first is we construct our cranks. Number D firing order is angle interval is 144, and we have 4-stroke engine. So each of this one we have our firing order 15243. 15243. 1. Start with 1, and then we go to 144. Okay, 144. Each of this one is 144. So 1, 5, 2, number 1 here, number 2, number 3, number 4, and number 5. So 1, 5, 2, 4, 3. Each of these should be 144. And for angle interval here, it should be 288. So 1, go to 5. This one is 288. 5 to, then what? 5 to 2 should be also 288. 2 to 4 also 288. And 4 to 3 288. So if you look at this condition, all primary cranks, so all primary force is balanced. Secondary force is also balanced. All right. So look at this one. So primary force angle is this is what I mentioned. Primary force is balanced. So no need to find the force. This one primary couple. Right? Before we go to secondary cranks, we can find primary couples. So if you look at this one, why direction of MRD like this? So look at the table, and you must refer to our primary crank here. Referring to this one, number one. Look at this number one. Number one, why downward? Should be here, isn't it? But since we know that our MRD is negative to MRD, so direction should be opposite to the below. And number two here, number two, since number two is negative as well, so direction should be opposite. And number three is 0 because our reference. Number four is MRD positive, and number five is here to MRD. So this one is not balanced. Not balanced. If this one is not balanced, then we need to analyze. So how to find the moment about x and y axis? Just just total up each of x and y. So for example, we have MRD sine for x axis first. MRD sine 72. Where is it? This one. MRD sine 72 because this is our x axis and this is our y axis. So MRD sine 72 plus MRD sine 72 here. This is 72. And then 2 MRD sine 36. 2 MRD sine, where is it 2? This one. 2 MRD, sorry, 2 MRD sine. So we have MX is 3.078. And MY is here 3.618. MRD cos 72 minus MRD cos 72 minus 2 MRD cos 36 and minus 2 MRD. Then our M should be MX is to the right and MY is downward. So our result of M should be occurs on fourth quadrant. Alright. Fourth quadrant. Fourth quadrant. So we can actually find what is our M. Alright, and then our beta here, then unbalanced primary couple must be for this one is MP. Alright, MP 4.75 MRD omega squared. So and then we need to investigate secondary force angle 2 theta. MR here, MR, this one secondary force is also balanced. So for secondary couple, referring to this secondary cranks, so again, based on the table, we have negative 2 MRD for number one. Where is it? Negative 2 for number one. So just downward here because negative. And then number two, where is number two? Here, this is number two. Negative, so opposite is here. MRD, and number 3 is here 0. Look at here 0, and number 4 is positive MRD, and number 5 positive. So remember, this is very important. This is our reference in order to allocate your moment each crank. All right, and then again you can actually find what is our MY. Sorry, this is MX. Sorry, what is our MX and what is our MY. Then at the end we get that we obtain that our moment occurs on the third quadrant, right? Because this is to the left and downward. So our unbalanced secondary couple must be M 1.562 MRD omega squared over N. Alright, so I think that's all for our lectures. So I think we stop here. Then so hopefully you understand what we uh, what I already explained here. So our next video is we are going to investigate or analyze for this example. All right, this is just only we cover on the first types of engine. We still have another two types of engine, which is radial engine and V-line engine. So for the time being, we already discussed about the first engine. Then next video is we discuss together on how we are going to investigate or solve this example number 3, or maybe I can give you solutions during WhatsApp or whatever. So just stay tuned, guys. So next videos maybe I will inform you later. All right, so thank you very much. Assalamualaikum.